If you have a look inside of the directory, which is your user's home directory, so now if you have a look at the output of the ls-l command, you can see that in our directory, we have the files that we have just created. Now, what we're going to be doing is reorganizing our files. You see, the MP3 files should go to the music directory. Similarly, the JPEG files should go into the pictures directory, as the AVI files should go into the videos directory. So here we're going to be using the mv command to move the files to their appropriate directories. Now, to further our reorganization endeavors, we're told to create some directories like friends, family, and work. So we go ahead, use the mkdir command, transacting against the three directories, and now we're told that we need to change into the friends directory, and we need to copy, and look at that path. We are copying the files from music song1.mp3, from music song2.mp3, from pictures snap1.jpg and snap2.jpg, and then from the videos directory, we are copying film1.avi and film2.avi. Now remember that we are going to be copying it to the directory that we are working in, and that is represented by that period. So that period is not a typo. It doesn't mean it's a full stop or punctuation in your student guide. We are copying it to the current directory. Next, we're told to go into the family directory. Now, look at that path over there. We're making use of a relative path. So double dot, because we are inside of the friends directory. We're saying go one directory level up. Then change into the family directory. And what we're going to do right now is from music, we're going to copy songs 3 and 4.mp3, from pictures, snap 3 and 4.jpg, and from videos, we're copying film 3 and film 4.avi, and we are copying it to the current directory, which is that family directory. Next, we're told to change into the work directory without changing into your home directory. So we're saying cd ... In other words, go to the parent of family, which is the home directory, and the directory that we are changing into is work. Then what we're going to do is that we're going to recursively copy two directories. So we're going to copy family, which is below home, and friends, which is below home, and all of its contents into the current directory, which is work. So now if you have a look at the output of ls-l, you can see that we have the directories, family and friends. Now, go one directory level down, which will take you to your home directory, and now we are going to delete the directories. We need to make use of the R option with the rm command. And now you can see that when I do an ls-l, you can see the contents of the student user's home directory. Now, once you're satisfied with your work, feel free to log out of Server A, hit Control-D, that's good enough. And what is really important over here is that you clean up any of the resources that were created. Now, you don't have to do so manually. All you have to do is run the lab finish files manage command. And with that, it brings this video to an end. I will see you in the next section. Hey everyone, right now we are going to have a look at making links between files. However, before we go there, we need to understand some identifying elements. Now, processes are identified by their process IDs, or commonly called PIDs. Users are identified by their user IDs. Groups are identified by their group IDs. Now, what about files? Now, you may be forgiven if you thought file IDs. That is not true. Files are identified by their index nodes, or commonly called inodes. An inode keeps track about everything about the file except for the name of the file. Now, inodes are file system specific. Now, if you are making use of the XFS file system, which is the default file system for Red Hat Enterprise Linux, it generates inodes of 512 bytes in size. And these inodes are generated dynamically. So as you create the file, the inode is created for that file. Every file has an inode. And the inode keeps track of things like the ownership, the permissions, the date and timestamps, and the actual paths to the data blocks that contains the file's data. The inode does not keep track of the name of the file. Now, the name of the file is the responsibility of the file allocation table. Now, the file allocation table, just to put it simplistically, has the name of the file and the inode that is associated with that particular name. Now, let's go and have a look at my demo-based system. So what I've done over here is that I've run the command xfsinfo against the root of my file system, because the root of my file system uses XFS, and what I want to point out is that we have the inode size of 512 bytes. Now, let's go and put that into play. In the training resources directory, I've got a file called Hello World. Look, there's Hello World. And if we want to get more information about that file, we can do a long listing. Now, if you want to see the inode that is associated with the file, you would use the I option. So all that I'm doing over here is using the command ls-li, and I'm showing you the contents of the directory, and I'm doing a long listing. And what I want to point out over here is that that number, which is dynamically generated, 1827, 8838, that is the inode that is associated with the file called Hello World. Now, there's a certain number that I want to point out right now. Look at that number 1 that I'm highlighting. That is called the link count. What the link count does is that it tells us how many names are associated with that particular inode. That's useful information, right? Nod your head along with me. Yes, it's very useful information. So there's one name that is associated with that particular inode. And if you look at the contents of that Hello World file, it says, Hello RH124 students. Now, to create a link, and the kind of link that we are creating over here is called a hard link. So what you can see is that we would use the command ln, the file that we want to link to, and that is Hello World, and then finally the second argument, that would be the link that we are creating. So ln, Hello World, and we're linking that to Red Hat Learning. Now, if you do a listing in the directory right now, you'll see that, yes, there are 2 files. One is called Hello World. The one is called Red Hat Learning. And if you look at the contents of Hello World, it says Hello RH124 students. And the same applies to the Red Hat Learning file. Hello RH124 students. Now, which file did I create first? Now, without you having seen me do that, it would be pretty hard for you to determine that information. Because if you have a look at the output of ls-li, you can certainly see over here that there are 2 files, Hello World and Red Hat Learning. And they have the same inode, right? Now, if they have the same inode, now go back to the whiteboard. If they have the same inode, that means that they would have the same ownership, the same permission, the same date and timestamps, and the same paths to the data blocks for that particular file. So the other thing that I want to point out over here is that very special number, which is the link count. So you can see that the link count over here is set to 2. What this is saying is that there are 2 names that are associated with inode 1827, 8838. Now, let me go and run the date command. And what I want to point out over here is that it is Monday, June the 6th, and it's 3:13 in the afternoon. And what I'm going to do right now is use the touch command against a file called Red Hat Learning. Now, we know what the touch command does, right? So when you use the touch command, and if the file does not exist, it creates a file 0 bytes in size of that name. However, if the file does exist, it updates the date and timestamp to that of the current date and time. Now, if you now have a look at the output of the ls-li command, what you will see right now is that Hello World and Red Hat Learning have an updated timestamp. You can see right now that it is 13 minutes past 3 in the afternoon. Previously, the timestamp was 12 minutes past 3 in the afternoon. Now, let's go and see what happens when we use the rm command to remove hello world. Now, what's going to happen is that if the link count is not 1, it's simply going to decrease the link count. It's going to remove that name from the inode. So what is happening over here is that because the link count is set to 2, it's going to remove the name hello world from that inode. So when you look at the output of ls-li right now, inside of the current directory, you will still see that there's a file called Red Hat Learning. And the file Red Hat Learning points to inode 1827-8838. Now remember that these inodes are generated dynamically. So your inodes are going to be different to my inodes. Now let's go and have a look at another use case over here. I'm going to do an ls in the current directory, and what I want to do is link training resources. That's the directory that already exists. I want to link it to a new directory called learning material. And you can see right now that it says hard link is not allowed for the directory. And that is because there are 2 limitations of hard links that I would like you to be mindful of. Hard links can only link files on the same file system. Hard links cannot link directories. So if you do want to use links for directories, and if you do want to link files across file systems, then you need to make use of symbolic links or symlinks. Now, what you can see over here is that we would use the same command, in other words, ln. The option, however, that we would use is the s option. So we are saying, let's go ahead and create a symbolic link, and the last argument is the link that you are creating. So we're going to be linking training resources to learning material. Now, if you have a look at the inode associated with, and this is an interesting one. So we are using ls-l to do a long listing, d to transact against the directory, not the contents of the directory, but the directory itself. I for the inode. You will see right now that learning material and training resources have the same inode, 1827-8818. However, if you do an ls-li and you don't use the D option, what you can see over here, and let me highlight this line, you can see that a very special file is being created, and you can see it's learning material. And look at how it's colorized differently. It's colorized differently to indicate that it's a special file. And that special file called learning material points to training resources, and it has its own inode. Now, that is how symbolic links work. However, it does come with a disadvantage. If you delete the directory that the symbolic link points to, or the file that the symbolic link points to, you end up with what is called a broken link. And again, look at how that is colorized. You can see over here, learning material points to training resources, and it does not exist. So let's have a look at a couple of use cases over here. If you have a look inside of the current directory, I've got a file called my shared lib version 1. So let's just say that you have an application and the application is looking for a library, and the name of the library that the application expects is my shared lib. Now, you currently have version 1 installed. So what you could do is that you could create a symbolic link. And what this means right now is that with this command, you are linking the name mysharedlib version 1 to a file called mysharedlib. And that is the file that the application expects. So your application is working very happily. However, there's an updated version of the library because perhaps there's a bug. Maybe there's an enhancement that you would like to take advantage of. So what you could do right now is that you could install the updated version. So if you have a look at the file mysharedlib, currently it points to mysharedlib version 1. Now I've got another file over here called mysharedlib version 2. There it is. And all that I'm going to do right now is that I'm going to go ahead and delete the link using the rm command. So rm mysharedlib, and then I simply go and recreate the symbolic link. And what I'm doing over here is that I'm linking the name mysharedlib to the existing file, the updated file, the file that gives us the new features called mysharedlib version 2. And now the application keeps on working. And the application is able to keep on working because it has access to the shared library that it expects. And the name that is expected is mysharedlib. Here's another use case. Let's just say that you've got this really complicated directory structure for your customers' website data. So I've got /vhosts /example incorporated /apps.example.com /HTML. Now, for your users, for your customers, it may be rather difficult for them to navigate to that path. You want to keep it simple, right? Complexity kills productivity. So what you could do is that you could simplify access for them. Now have a look at this command over here. ln-s, we are linking vhosts, example link, apps.example.com, HTML, and we're simply putting that inside of /home student HTML. And what that means is that the customer, in other words, the student user, simply goes to their home directory, they change into the directory HTML, and of course they can work inside of that directory, which is way simpler. So if you have a look at the listing of the home student directory over here, you can see HTML and what it points to. Links are awesome, and you should make use of them. In fact, your operating system uses links rather extensively. Now, I'm sure that you want to get your hands dirty, so head on over to the next video, and I'll meet you there for the guided exercise. Hey everyone, right now we are going to have a look at the guided exercise. Of course, we are focusing on making links between files. As always, we need to get things kick-started by running the appropriate start command. So from the workstation machine, run the command lab start files make. Of course, you need to make sure that you have your successes before proceeding. Now, make an SSH connection to server A. And once you have made an SSH connection to server A, do a long listing of the files directory and specifically a file called target.file. So that file is already there. And what we are now going to do is that we're going to create a hard link that points to target.file. Now, the link that we are creating is target.hardlink. Now, let me highlight the command over here. Of course, we're going to use the ln command, but there's no ways that I typed out all of that text. You see, I took advantage of argument history. Now, do you remember how to do that? Yes, that's right. Escape dot. So what I used over there was ln space, escape dot, space, and then I hit escape dot again. And then I just backspaced the word file out and replaced it with hard link. Now, afterwards, use the ls command and address files target.file, files target.hardlink, and again, take advantage of your argument history using escape dots. And it's worthwhile pointing out over here is that there are two names associated with the inode. In other words, the link count is set to 2. Now, next, what we're going to be doing is creating a symbolic link. So we use the ln-s command. So what we are doing is that we are linking /tmp and we are linking it to a new name called home student tempdir. So remember, the argument that comes last is what you are creating, the link that you are creating. So if you have a look at the contents of home student tempdir right now, you can see that it points to /tmp. Once you're satisfied, hit Control-D, log out of server A, clean up your work, and it's as simple as running the command lab finish files make. And with that, it brings this video to an end. I will see you in the next section. Hey everyone, right now we are going to have a look at one of my favorite topics, which is about matching file names with shell expansions. Now, let's go to the whiteboard. What I want is for the directory structure vhosts below the root of my file system. Now, below vhosts, I would like to have 3 subdirectories: www.redhat.com, www.ansible.com, and www.openshift.com. Now, each one of those subdirectories should have an HTML as well as a CGI bin directory. Now, I'm a lazy person, and I mask that by saying that I like to work smarter instead of harder. But in essence, I'm a lazy person. Now, let me show you the lazy approach to creating this entire directory structure. So let's go to my demo-based system over here. So let's start by creating /vhosts below the root of the file system. And you can see that that was created. And there's no voodoo over here, okay? So when you have a look at the output of tree-f, you will see that there is vhost and there are no directories and no files below that directory. Now, look at this particular technique over here. Yeah, I'm using the mkdir command -p to create the paths. To create the paths, should the parent directories not exist, the -v does it verbosely, so it provides additional output. And you can see over here that we are creating vhosts, then www. Now, what comes within the curly braces over there would be the differences between the various directories. Now, have a look at the whiteboard for a moment. You can see that they all begin with www. And they all end in .com. The part in the middle between the two periods, that is the difference. So what I've done over here is that I've opened up the curly braces and I've comma separated the words Ansible, OpenShift, and Red Hat. And what this does is that it results in the directory structure being created vhosts, www.ansible.com, vhosts, www.openshift.com, and vhosts, www.redhat.com. But I didn't stop the command over there because I had another /, and you can see that what I did is that below each directory, I also created an HTML as well as a CGI bin directory. Now, if you have a look at the directory tree, this is precisely what I wanted. So if you go back to the whiteboard, you can see that what exists in reality with one command is what was reflected on the whiteboard. Now, another really cool command that I want to show you, and we know about the touch command, okay? So you can see over here that I've created a couple of files. So within the curly braces, I have index, info, and insights.html. And you can see over here that when I do an ls-l, the files certainly do exist. Now, oops, my bad. I created them as .htm instead of .html. Now, one of the lesser known commands is the rename command in Linux. And the rename command works a little bit differently. So the command is rename. What would you like to match to? I would like to match to the extension of .htm. What are you going to rename it to? .html. For which files? And now the asterisk represents all of the files in the current directory. So for all the files in this directory, we're going to change the .htm part to .html. And here you can see that we have index.html, info.html, as well as insights.html. Now, what you can also do is that you can use an asterisk to do some additional pattern matching. So you can see over here that when I do an ls-li asterisk, you can see that it matches to the files that I expect. Now, something else that we could do is use sequential ranges. So right now, we have a couple of different versions of Red Hat Enterprise Linux that are out in a lot of data centers. And what I would like to do is to create a subdirectory representing each version of RHEL. So mkdir-pv rel, and you can see a sequential range, 6.9. And you can see right now we have our directories that are created. For the record, it is possible for you to upgrade to Red Hat Enterprise Linux 9 if you're using Red Hat Enterprise Linux 8. In fact, you can do an upgrade from RHEL 7 to 8, then from 8 to 9. In fact, you can do this. You can upgrade from RHEL 6 to 7, 7 to 8, 8 to 9. Remember, your subscription is not linked to a particular version of Red Hat Enterprise Linux. Now, if you have a look at the output of ls-l, you can see the structure that I have inside of the current directory. Now, what I've done is that I've changed into the directory www.ansible.com. Look at the prompt over there. It reflects the directory that I'm in. Now, if I do a listing inside of the directory, I've got a couple of file names right now, like assert, fail, fetch, find, file, and yum. And what I want to do is that I want to move those files into the HTML directory. So what I did is that I took advantage of tab completion. Now, certainly, what I could have done is that I could have said MVA asterisk, F asterisk, Y asterisk. But you know, that was way too much typing for my liking, and I'm a lazy person, as you know. So what I did over there is that I used the MV command, A tab, space, F asterisk, space, Y tab. And then I said H tab, and it completed it to HTML. And when I do a change into the HTML directory, and if I wanted to display all of those files that begin with F, I don't care how many characters come afterwards, I could use that asterisk. So based on the output of this command over here, you can see LSF asterisk. It matched to fail, fetch, find, and file. Now, if I only wanted to match to F and 4 characters afterwards, I can use a question mark. So what the question mark does is that it matches to any single character. So ls-f and then 4 question marks matched to fetch, because that's the only file that begins with an F with 4 characters afterwards. Now, a couple of other techniques that I want to share with you. If you have a look at this tab over here, the directory that I'm working in is USR shared doc. And if you just type in CD on its own, of course, it will take you to your home directory. And based on the output of PWD, you can see that my home directory is in fact /root. Now, another way that you can change to your home directory is using a tilde. So that tilde will say, right, let's go and change to your particular home directory. However, you can also use this technique. So I could say cd tilde and then another username. And what that will do is that it will take me to the home directory of that particular user. So if you have a look right now at the output of PWD, the directory that I'm working in is /home/student. Remember, you can also make use of cd- to change to the directory that you were previously working in. Variables are important to any programming language, and you can also take advantage of bash to do scripting, and it's really easy to create a variable. It's as easy as this. You say variable equals and then a value. And the common convention is to have your variables in uppercase characters. Of course, the values can be whatever case you decide. Use variable names that make sense in your solutions. Now, if you have a look over here, I'm creating a variable called first name. So it's really as simple as this. First name equals Ricardo. Surname equals DaCosta. Now, my surname has got a space inside of it. So what I'm doing is that I'm encapsulating it with double quotes so that it can preserve that space character. And then I can use it in a simple sentence like echo, which will print text onto the screen. Now, when you reference a variable, you would prefix it with a $sign. So echo, I am, $first name, space, $surname. And you can see that the result over there is I am Ricardo DaCosta. Now, your variables may contain some special characters like underscores. Now, what I want to show you over here is that if I can separate the variables first name and surname with an underscore, look at how that transforms the output. It simply says, I am DaCosta. So the question is, what happened to the first name? Well, you see, what the shell did is that it thought that the variable that you were referring to is first name underscore. And there is no variable called first name underscore. The variable is quite simply called first name. Now, what we could do is that we could put boundaries around our variable names. And this is good programming practice. And how you would go about doing so is using curly braces. So you can see over here, around the variables names would be the curly braces. Of course, they'd have a prefix or the $sign to indicate that this is a variable. But you can see right now that it prints, I am Ricardo underscore DaCosta. A common question that I get is, well, I made a mistake in a variable. How do I fix it? Well, what you could do is that if you create a variable like my email, I've got the value over there, ricardo@redhat.com. And you can see that over here, when I say echo my email, it says ricardo@redhat.com. Well, that is not my email address. However, my email address is rdacosta@redhat.com. So all that I need to do is redeclare the variable. My underscore email equals rdacosta@redhat.com. Now, if you completely want to unset a variable, you can use that command. Unset space and then the variable name. However, in my case over here, you can see that my email was simply updated. Now, let's go and use that variable in a sentence. What I want to do is that I want to say the variable my underscore email provides my email address, which is, and then the value of my underscore email. So if you have a look at this command that I'm highlighting over here, look at the output. Now let me go and make it a little bit clearer for you. Here's the result of the command. It says the variable rdacosta@redhat.com provides my email address, which is rdacosta@redhat.com. That doesn't make any sense. What I want to do is that I literally want to print the variable. So what I could do is that I could use a backslash to take away the special meaning of the dollar sign. Now, the dollar sign is used when we reference variables. So if I put a backslash in front of the dollar sign or in front of any special character for that matter, it will take away the special meaning of that character. So have a look at this command. The variable backslash dollar my email provides my email address, which is dollar my email. Now look at that. Look at the result. It says the variable, and now it literally prints the name of the variable, provides my email address, which is rdecosta@redhat.com. Oh, this is such a cool technique. Let me explain what's going on over here. I have a very important configuration file, and it's called myconfig. And what I want to do is that I want to make a copy of it, given the extension of .back. I just love this technique. So cp my_config, and then in curly braces, comma, .back. And what it does right now is that if you have a look at the output of ls-l myconfig star, you can see that there are two files, my_config and my_config.back. And this is a common technique that I would encourage you to adopt when it comes to modifying critical configuration files. Make a copy, and then go and change the original file. Of course, if anything goes wrong, you have a backup to restore from. Now, something else that you can also do, and you can see this technique over here, is called command substitution. What I'm doing is that with dollar and then the parentheses, I can put a command. And what's going to happen is that that command will execute and will have the result in place. So for example, what I'm doing over here is that I've got a file called myconfig. And what I want to do is to have a copy of the file called my_config dot, and then the result of the date plus %f command. This is a great technique, and yes, it is a little bit more complex, but you can see over here, the curly braces, comma, and then the extension that I want to use, dot, and then it's dollar, parentheses, date plus %f. Obviously, close your parentheses, close your curly braces, and now when you have a look at the output of ls-l myconfig star, you can see the different files that I have created. myconfig with the date, and myconfig.back. That's how easy it is. And this is the, dare I call it again the lazy person's approach? Or is it the smart person's approach? You decide. However, that concludes this video. I will see you in the next section. Hey everyone, right now we are going to have a look at the solution for the end of chapter lab, which is all about managing files from the command line. Let's go and get things kick-started by running the start script. Here we are going to run the command lab start files review from the workstation machine and make sure that you have that success before moving along. Now, next, we are going to make an SSH connection to server B as the student user. And our objective right now is to create a directory called project plans below documents, which is in the home directory for the student user. Then what we are going to do is create below documents, below project plans, we're going to create two files, season1_project_plan.odf, as well as season2_project_plan.odf. And you can see that when you have a look inside of the documents directory, you can see that we have project plans, and below project plans, we have our two ODF files. Now, next up, what we are going to do is to create some additional files. And you can see that we are using touch. TV season 1,2_episode, and look at that sequential range 1.6.org. Of course, encapsulate your pattern matching within the curly braces. So you can see right now that when we do an ls against TV asterisk, you can see that we have the necessary files that we are expected to have created. Next, we are going to create some ODF files, some document files, and they're going to be called mystery_chapter, and we are creating files 1 through to 8. And if you do a listing right now against, let's just use MYS asterisk, you can see that the files were indeed created. Let's go and organize them right now. So, from server B, in the student user's home directory, we are going to create a subdirectory called season 1 and season 2 below videos. And you can see right now that we have videos, and then video season 1 and video season 2. And what we are now going to do is move all of the files that begin with TV_season 1 below video season 1. Similarly, we're going to move the files TV_season 2 below video season 2. And you can see the use of the asterisk there after the file names. So if you look at the output of tree-f against videos, what you should find is videos, then you have season 1, and then below season 1, you would have season 1's episodes. And the same is applicable to season 2's directory. You'll find season 2's episodes below the season 2 directory. Now, next up, what we are going to do is to create the directories chapters, editor, changes, and vacation. And these are subdirectories of a directory called my_bestseller, which is to be created below documents. So look at the mkdir command being used with the -pv option. So if you look at the tree right now that was created inside of the documents directory, you will see that we have my bestseller, and then below that we have changes, chapters, editor, and vacation. And of course, we have the project plans directory that was previously created. So what we are going to do right now is change into documents, and then my bestseller, then chapters. And what we're now going to do is that we're going to move all of the files that begin with mystery_chapter from within the user's home directory into the current directory. So remember that current directory, and you're not seeing things, that is not a typo. That is not a form of punctuation. That dot, that period, represents the current directory. So while you're inside of the chapters directory, if you do a listing right now, you will see that the files are present because they have been moved. Next, what we're going to do is that we're going to use the mv command, and we're going to move mystery chapter 1 through to 2.odf, and we're going to move it to the editor directory. Now, the editor directory is below, one level below chapters. So we use /editor. So if you have a look at the output of the ls /editor command, you can see the files that were moved. And we did so without changing from the chapters subdirectory. Now, let's go and move mystery chapter 7 and 8.odf to vacation. Now, vacation is one directory level below chapters. So we're going to use /vacation. So now when you run ls.vacation, you can see mystery chapter 7 as well as mystery chapter 8. Now, let's go and change into below our home directory, video season 2. So now what we are going to do is copy all of the files that end with episode1.org, we're going to copy that to, in the home directory, documents, my bestseller, vacation. And again, if you do an ls, and take advantage of escape dot, work smarter, not harder. So ls, escape dot, and that will recall the argument, in your home directory, documents, my bestseller, vacation. And here you can see the files that are expected. Let's go and do the same thing right now for episode2.org. So copy asterisk episode2.org, and we're going to copy it to the same location. So use escape dot again. And of course, you can do your validation afterwards using the ls command. Now, let's change into my bestseller. So my bestseller is in our home directory. It's below documents. And what we are now going to do, and look at that technique, here we're going to copy from chapters, mystery chapter 5, as well as 6. So we use the square brackets over there, .odf, and we're going to copy that to changes. So now when we do a listing against changes, you can see the files are present. So it matched to mystery chapter 5 and mystery chapter 6. So let's go and change into the changes directory. And now what we're going to do is that we're going to copy mystery chapter 5.odf, and we're going to give it the extension, which includes today's date. So run the command that you see on screen right now, and you can see the use of command substitution. So we're going to do that for mystery chapter 5.odf as well as mystery chapter 6.odf, and you'll see that the file name will contain today's date. Now, what we're told to do next is, from the changes directory, we're going to use the rm command, and we are going to remove the contents of the changes directory. Then we're going to go one level down, cd ... and we're told, run the rm command without any additional options, and you'll see that we failed to delete the changes directory. So now what we're going to do is use the rmdir command. We can use that command to delete a directory because it is empty. However, if you want to delete a directory that is not empty, what you could do is use rm-r, and that is precisely what we are doing against the vacation directory. So what we are going to be doing next is create a backups subdirectory below documents. And now what we're going to do is create a link. So the link that we are creating, let me highlight it, is the last argument. So the full command reads ln. What we are linking to is, in the home directory, documents, project plans, season 2 project plan.odf. And the link that we are creating is, in our home directory, documents, backup season 2 project plan.odf.back. Now, when you are ready to grade your work, go ahead, run the command, lab grade files review, and hopefully you have a pass. I certainly hope that you have a pass. Now, if you don't, fear not. One of the cool things about using these grading scripts is that you can run them over and over again. So what that means is that if you don't have an overall pass, you can go back, you can refactor, and you can regrade. And once you are ready to wrap things up, all you need to do is run the command lab finish files review. With that, it brings this chapter to an end. I will see you in the next video. Hey everyone, it's time for a brand new chapter, and this is a very important one. And here's why. You can't remember everything. You can't remember every single command. You can't remember every single option. And that is why we have man pages for you. Now, there are several sections with respect to man pages, and your student guide will reference 9 sections. However, let me tell you about the 3 that are of importance to us. So, section 1 is all about user commands. We have section 8, which is all about admin commands and daemons. Now, what I want you to think about over here is that section 1 is your basic commands that every single user can make use of, like the ls command, like the cp command. So if you want to know more about how to make use of, let's just say, the cp command in particular, then what you could do is that you could go to the man page for the cp command. Now, similarly, section 8 covers administrative commands as well as daemons. So for example, if you are using the Apache HTTPD web server and you want to learn more about the options that you could use with Apache HTTPD, then you would go to section 8. However, one of my favorite sections is section number 5. And what section 5 is all about is configuration files. Now, configuration files influence the behavior of various aspects of your system. So for example, there are configuration files for web services. There are configuration files for SSHD. There are configuration files for many things. And if you want to learn more about the directives that could go into a configuration file, why don't you look at the man page for a config file? And config files all belong to section number 5. There's no need for you to remember every single thing. Now, let's go and have a look at my demo-based system over here. If you want to search for a man page, you can make use of the command man-k, and then you could specify a keyword. So let's just say that you heard about something called cron tab. You can see over here that we have various man pages that cover cron tab. Now, we're not going to go through every single section and subsection. However, I do want to point out the 3 sections that I have on the whiteboard right now. So 1 is all about user commands, 5 is all about config files, and 8 is about admin commands and daemons. So what we can deduce over here is that cron tab is not an administrative command, and it's also not a daemon. We have cron tab that is a normal user command. Let me highlight that over there. And we also have cron tab that is a configuration file. Now, let's just say that you want to access the man page. It's really simple. You would say man space and then the man page that you want to access. So in our case over here, we could type in man space cron tab. But remember, we have 2 matches to that word cron tab. We have cron tab that belongs to section 1 and we have cron tab that belongs to section 5. Now, if you don't specify a section number, it's going to go for the lowest number. So in our case over here, typing in man cron tab is going to call up section 1. Now, look at the top left and right corners. This is where it tells us about the man page along with the section number that we are looking at. And right here in the center, it gives us a description of the section. So it says that this is all about cron tab, which is about user commands because it belongs to section 1. Well, the name further clarifies that, maintains cron tab files for individual users, and then very importantly, the synopsis tells us how we would go about making use of the cron tab command. Now, let's have a look at this over here. In this first example, what it's telling us is that we can make use of the cron tab command, and then within square brackets, that component is optional. In other words, the cron tab command can run without that particular component. So you could say cron tab and then optionally -u, and then you could specify a username. Also, what you could do is that you could say cron tab and then you could specify a file, or you could specify a dash. Now, you may notice that pipe over there, right? That's a vertical line going downwards. That's the pipe symbol. So what this tells us is that we can either make use of cron tab space file, or we can make use of cron tab space dash. You won't be able to make use of both of them at the same time. Now, let's have a look at the next example over here with respect to the synopsis. It says that we can make use of cron tab -t. Now, the -t is within square brackets, and that is an optional component. And what you could also do is that you can make use of cron tab, and then you could specify a file, or you could specify a dash. Again, those characters are separated by a pipe. Now, this is an interesting one over here. In this example, you can see that within the square brackets, we have the -u. So that component is optional. And then, and allow me to highlight this part over here. Can you see within the greater and less than signs, we have a couple of options, -l, -r, and -e, and they are separated by pipes. So again, what this is telling us is that we can make use of the cron tab command, and we can either say cron tab -l, or cron tab -r, or cron tab -e. Those options are mutually exclusive. You can't use them together. So it's not possible for you to use a command like cron tab -l-r, for example. And again, you can see over here that we have the dash I and the dash S within the square brackets. And the remainder of it is quite simple, right? So you could say cron tab dash N. Optionally, you could specify a host name. You could say cron tab dash C, cron tab dash V. Now, the purpose of the man page is that it tells you how to make use of your commands, whether they are normal user commands or administrative commands, or how to make use of configuration files, which directives could go into configuration files, and what their possible values may be. That is the purpose of the man page, so that you don't have to remember every single thing. So when it comes to the question of, hey, what does the dash R mean within the context of the cron tab command? We can determine that by having a look inside of the man page. However, I've got a question over here for you. I want you to think about this scenario. Can you run the cron tab command on its own without specifying any options? In other words, could I type in cron tab just on its own without the command being errant in any way? So let's go and think about that over here for a moment. We have a look at the synopsis, right? So what I'm going to do is open up a new tab, and I'm going to type in cron tab on its own, and let's see what happens. It says, sorry, you won't be able to do that because we either need to specify a file name or we need to make use of a dash for standard in. That must be specified. So if you go back to the synopsis over here, is that it tells us that cron tab can be used, and either we must specify a file or we must specify the dash. You see that component that I'm highlighting right now, that element that is not within square brackets, that is a mandatory component. So we could say cron tab, and then we could specify a file, or we can specify a dash. Here we have a similar example. We could use the dash T, but then we have to specify either a file or the dash. So within that greater than sign and less than signs, those specify mandatory components. Remember, the pipe sign or the pipe symbol tells us that these are mutually exclusive options. Now, there's a lot of data inside of man pages, and it's worth your while to know how to search within inside of a man page. And it's really simple to do. Use a /. Now, look at the bottom left corner. What I'm going to do over here is do a search for the word user. And you can see it highlights the various iterations of user. And if you want to sort of scroll between them, you can use N on your keyboard. So for example, if you want to learn more about what cron tab dash, let's just say E does, we could do a search for dash E. So let me go and use / dash E, enter. And it says what the dash E does is that it edits the current cron tab using the editor specified by the visual or editor environment variables. After you exit the editor, the modified cron tab will be installed automatically. Now we know what the E does. You see, you don't have to remember every single option. You don't have to remember the various directives that goes into your config files. Use the man pages for that. Work smarter, not harder. Now, I want you to notice an interesting behavioral trait over here. I'm going to hit Q to quit out of a man page. And when you quit out of a man page, it clears the screen. So what we can do is that we can influence the man command to not clear the screen whenever we quit. Whenever we quit using the Q command. Now, the Q command is used with the less viewer. So what the less command allows us to do is to look at the contents of a file. And what is really cool about it is that we can look at the contents of a file page by page. And what is so nice about it is that we can go down one page at a time, up one page at a time. We can go down one line at a time, up one line at a time. We can do searching. It is so very capable. And the less command replaces a much older command called more. And there's often this joke about less being more. Now, what we want to do over here is that we want to tell the man command, which uses less in the background, not to clear the screen when we quit. Because sometimes we want those examples, we want the options on screen so that we can make use of them immediately. Now, how you would go about doing that is that you would create an environment variable called less, and you would give it a value of dash capital X, like that. Now, you may want to stick that in a login script. I will teach you about login scripts a bit later on, but this needs to be set inside of your login script so that it is persistently available. And what I'm now going to do is that I'm going to go back into the man page for cron tab, and I'm just going to do a search for -E. There we go. We have -E, all about editing the current cron tab. Now look at what happens when I hit Q on the keyboard. It doesn't clear the screen. This is really cool stuff, isn't it? Yes, I'm sure that you agree. Now, let's go and have a look at the next tab over here. If you want to access the man page for a different section, then what you would do is say man, then the section number, and then the man page that you want to access. Now, hitting enter over here, you can see that we're in a very different man page. So it is related to cron tab, but it's not about using cron tab as a command. It's all about cron tab as a configuration file. So you can see that cron tab, it's all about files used to schedule the execution of programs. And you can learn more about it over here. We can go down one page at a time. We can go up one page at a time. We can use the arrow keys to go one line down. And we can use the up arrow to go one line up again. And don't forget that we can do a search. So all that I'm going to do right now is say / look at the bottom left corner. I'm going to type in the word hour, and there we go. And you can see that we have various matches to hour. And of course, we'll go to the next match. And when I hit Q, look at that, it clears the screen. Now, it clears the screen because in this terminal tab, that environment variable called less has not been set. So like I said, you would typically do this inside of your login script. Now, what I'm going to do right now is that I'm going to recreate that environment variable because it is a brand new tab and you would typically set this inside of your login script. So I'm going to say export less equals -x, enter. And this is the real magic of using this particular environment variable. I'm going to say man, tmux. To learn more about tmux, the terminal multiplexer, I'm going to do a search right now for examples. So look at the bottom left corner, /examples. Look at that. So here we have a couple of examples as to how we can make use of tmux. Now hit Q and look at that. The examples remain on screen. And what I could do right now is that I could use my terminal and I can run tmux related commands based on the examples that I have on screen. It's all about working smarter and not working harder. Now, I'm sure that you want to put this into practice, right? Of course you do. So head on over to the next video and we'll meet each other there for the guided exercise. Hey everyone, let's go and put into practice what we just learnt about right now. It's the guided exercise focusing on reading manual pages. Let's go and get things kick-started by running the command lab start help manual. You need to make sure that you have those successes before proceeding. So first up, we need to learn more about how to make use of the gedit command. So of course you would use man gedit, and you can have a look at the synopsis over here. So what you could do is that you could say gedit, and then inside of the square brackets over here, we have an option that you can specify. Now, if you look at that, you have the ellipsis. Now, that ellipsis says that you can make use of several options together with the gedit command. So you don't have to only make use of one option. You can also make use of gedit and you could specify a file. Of course, specifying a file is optional. However, should you want to specify a file, you could specify more than one file as a result of the ellipsis. And then what you can also do is that you could specify a line that you would like to open up gedit at. Now, what we are going to be doing is opening up a file, which will result in the cursor being at the end of the last line. Let's go and have a look at that. So it's gedit space plus space manual. And there you can see the cursor is at the end of the last line. This is the first line. The quick brown fox just came over to greet the lazy poodle. Next, we're told to go and learn more about the su command. So the su command is all about substituting your user ID. And if you didn't know that, then you would go to the man page, of course. Now, running the command man space 1 space su is going to take you to section 1 of that particular man page. Now, look at what happens when I don't specify the 1. takes me to the same man page. So remember that if there are multiple matches, then it's important for you to specify the section number. However, if the section that you are wanting to look at is the lowest numbered one, it's going to go there anyway. So SU is all about running a command with a substitute user and group ID. And again, you can have a look at the synopsis over here. So what you could do is that you could specify SU and you don't have to specify anything else. However, you could use SU and then you could specify options. You could use a dash. You could specify a user, and then you could specify several arguments. However, all of those components are optional as a result of them being inside of square brackets. So, of course, what we could do is scroll through that man page, and we can have a look at the various options and what they mean. Next, we're told to have a look at the man page for the man command itself. So it's quite a weird command that, isn't it? Man space man. So hitting enter over here tells us that man, an interface to system reference manuals, and it tells us how we would go about using the command and what it's all about. Now, what the where is command does is that it tells us where binaries are, where man pages are, and here we are told to go and run the where is command against parsewd. So it says that we have a binary called parsewd, usr bin parsewd. There's a config file called parsewd, etc parsewd, and here you can see that we have several man pages. So generally what we do is that we compress the man pages so that they occupy less space. The man pages are stored below usr share man, and then we have different directories representing section numbers. And then as part of the file name, we would have the name of the man page, the section number, and then the extension of .gz. Now, if you want to learn more about the various ways that we could zip, you can make use of man-k. Now, remember what the k does? It does a search, right? So using man-k zip, it tells us about the various man pages that match to that particular string. So next, what we're going to do is run man-k boot, and we're going to find the man page that will give us a list of the parameters that can be passed to the kernel at boot time. And there's going to be quite a bit of output over here. In fact, there are 60 lines. So let's go and scroll a little bit further up. And we'll teach you about regular expressions a little bit later on. However, over here, you can see that there's a man page called boot param. And boot param belongs to section 7. And it's all about an introduction to boot time parameters of the Linux kernel. So what I want you to remember over here is that we have a reference of the various sections inside of the student guide. And section 7 is all about conventions, standards, and miscellaneous elements. So next, we're told to go and find out which man page has got information about tuning the ext4 file system. So the command that we use is man-k ext4. And you can see that we have a reference over here to tune to fs, all the way at the bottom over there. And it belongs to section 8. Section 8 is all about administrative commands as well as daemons. And you can see the description is adjust tunable file system parameters for ext2, 3, 4 file systems. Once you're happy with your work, go ahead, wrap up by running the command lab finish help manual. And while this brings this particular guided exercise to an end, what comes up next is the end of chapter lab, where you will put your skills to the test. So work through the end of chapter lab on your own. And if you struggle and if you need my help, head on over to the next video where I'll walk you through the solution. Hey everyone, let's have a look at the walkthrough for the end of chapter lab, which is all about getting help in Red Hat Enterprise Linux. Of course, we need to get things kick-started by running the command lab start help preview, making sure that we have these successes before moving along. So first up, we're going to find out how we could format a man page for printing. So use the command man space man to learn more about how to make use of the man command. And now we're going to do a search for the word print. And if you scroll just a little bit further up, the first match over here has got to do with the option of T. So man-T, and then you could specify the man page that you want. So what we're going to do right now is that we're going to create a PostScript printable file for the PassWD man page. So in our case over here, we're going to run the command man-T, then the man page, and we're going to redirect that to passwd.ps. And we'll learn more about what that greater than sign, what the redirection means in the next chapter. So now if you do an ls, you can see that we certainly do have a file called passwd.ps, and you can see that it does certainly have some content. Now, just to verify that it does indeed contain PostScript printable content, we can make use of the file command. So remember, what the file command does is that it tells us what kind of file something is. And you can see that it is a PostScript document text conforming to DSC level 3. So let's go and have a look at the passwd.ps file using the less command. And you can certainly see over here that it does have some content. So what we're now going to do is use the man-k command to find out about which programs we can use that we could use to open up this particular file. So run man-k, and we're going to use two words, PostScript and viewer. And you can see that we have a couple of different options over here. And what we are going to be using is the events command. And you can see that events is the GNOME document viewer. Now, if you want to find out how to make use of events, of course, use man space events. And you can learn more about the options that you can make use of. Now, what we are going to do is open up passwd.ps 3 times. The first time we're going to do it is using default mode. So run events space passwd.ps. Next, we're going to open up that same file using preview mode. So if you go back to the man page, it would have told you that you could use the W option in that case. So use the command events-w passwd.ps. And you can see this is in preview mode. Close the window, and now we're going to open up a third and final time, and we're going to go straight away to page number 3. So based on what we learned about how to use events in the man page, the option that we would use is -i and then the page number. So run events-i 3 passwd.ps. And you can see that immediately on the left-hand side over there, we are indeed on page number 3. Next, we're going to learn more about using the LP command to print pages. Of course, we don't have a printer, so we're not really going to print any pages. So run the command man space LP, and you can learn more about how to make use of the LP command. So if you have a look at the synopsis over here, you may notice that the -P option is all about specifying a page list. And if you do a search for more detail, look at the bottom left corner, /-P. And let's go to the match. There we go, -P, and you can specify page list over there. So next, we are going to open up Firefox to browse the directory USR share doc. So what you can see is the contents of that particular directory. And what we are now going to do is a search, and we're going to look for kexec tools. So use Control F, and if you look at the bottom left corner, you can see that there's a search bar. So let's go and do a search for kexec, and you can see the first match over there is to kexec tools. So let's go ahead, open it up, and you can see that there's a file that we're told to go and explore, and that is kexec kdump howto.txt. And again, you can see how easy it is to read using the web browser. Once you're satisfied with your work, of course, you can grade it, running the command lab grade help preview, and it's going to check to see if that passwd.ps file exists. Remember, we created that file using the man command with the T option, referencing the man page, passwd. And then we use that redirect symbol to send the output to passwd.ps. Once you have your pass, don't forget, clean up your work, and you would do so using the command lab finish help preview. And with that, it brings this chapter to an end. I will see you in the next video. Hey everyone, it's a brand new chapter, and first up, we are going to learn about redirecting output to a file or to a program, and I want to take this to the whiteboard. I want you to understand that we have various communications channels. The three most important ones are 0, 1, and 2. 0 means standard in, and standard input typically comes from your keyboard, right? That's how you would give input to your system. Now, how your system communicates with you is using channel number 1 or standard out. And that is typically your monitor, right? So think about you running a command, you submitting input via the keyboard, and what's going to happen is that your system will give you output through the monitor. Now, similarly, we're able to differentiate between successfully processed messages and errant messages. And that is why we have channel 2, which is called standard error. And errors, again, go to your monitor. What we could do is that we could take advantage of redirection, and we have various characters that represent where input or output come from and go to. So for example, the less than sign is the redirector for standard input. So we could say, we're not going to get any input from the keyboard. Instead, we're going to get input from another file. Similarly, when it comes to standard out and standard error, what we could do is that we can make use of a single greater than sign, which means send the output of a command to another file. Or we can say 2 greater than sign, which means that we're going to take the error messages and we're going to send it elsewhere. Now, when it comes to standard out or the monitor, what you could do is that you could either make use of a greater than sign or technically 1 and then a greater than sign. Although almost no one does it that particular way. But I just want you to know that there's certainly 1 greater than sign that certainly does work. One of the other really cool techniques is the pipe symbol. I love using pipe. And what I want you to think about right now is that we have this vertical line and there's a hole in this vertical line. And that is where we put the pipe. Okay, so what we would do is that we would separate commands using a pipe symbol. So how it works is that the output of command 1 is sent through the pipe as input for command 2. So command 2, which comes after the pipe, it would get its input from command 1. That is the cool way of thinking about using the pipe symbol. Now, of course, we are putting this into theory over here on the whiteboard. However, you want to see this in action, right? So yes, not along. Let's go and have a look at the terminal over here. So very simply, I'm going to use the echo command and I'm going to say echo hello world. And what it does is that it prints the result of the command to standard out. In other words, the monitor. And what I could do is that I could use echo hello world and I could send that output, instead of being sent to the monitor, I can send it to a file called greeting. Nice and simple. And what you can see right now is that the file greeting certainly does exist. It was created as a result of redirection. And the content is hello world. Now, next what I'm going to do is say echo welcome to training. And again, the greater than sign over there is being used because I'm redirecting the output to the file called greeting. Now, if you look at the file greeting, it says, welcome to training. And you're thinking, hang on a second, what happened to hello world? You see, when you redirect in that way, using a single greater than sign, it will overwrite any existing content. So be very careful. Now, let's go and have a look at recreating that file over here. Now, based on what we had learned about in the previous chapter about using man pages, what you could do is that you can have a look at the man page for the echo command. And we can use these special characters with echo-e, and they won't be interpreted as literals. So that \n means a brand new line. So I'm printing hello world, and then I'm going to terminate that line, start a new line, and then I'm going to have welcome to training. And what I'm doing is that I'm redirecting that to a file called greeting. So if you look at the contents of greeting over here, you can see hello world. So we ended the line over there. We have a new blank line. And then we have welcome to training. Now, what I next want to do is that I want to put in the string, my name is Ricardo da Costa, and I want to add that or append it to the existing file called greeting. So what I'm doing over here is using echo-e, and again, you can see the use of that \n. So on a new line, we're going to be adding, my name is Ricardo da Costa, and we are going to append that to the file called greeting. So now if you have a look at the contents of the greeting file, you'll see that hello world and welcome to training is still there. And we have that brand new line that was appended called, my name is Ricardo da Costa. Now, another example of using redirection, using both standard output as well as standard error, is I want to show you the contents of my current directory. So what you can see is that there certainly is a file called greeting. What I'm going to do is use the ls-l command against two files, greeting and foo. Now, greeting does exist, however, foo does not exist. So what you can see over here is that I'm using a greater than sign and I'm redirecting the output. The successfully processed messages are being redirected to a file called success. And over here, to greater than sign is that I'm redirecting the error messages to a different file called failure. Now, no output went to my screen. All output, both the successfully processed messages and the error messages, was sent elsewhere. So if you have a look at the contents of success over here, you can see that we have the listing of the greeting file. And then if you have a look at the output of failure, you can see that we have the result of the ls command transacting against the file called foo, and the error message that was returned is cannot access foo, no such file or directory. Now, here's a cool command. You have the top command, and the top command is going to show us the processes that are using the most CPU. I'm going to use it in batch mode, and I'm using -n1 because I want one iteration. So it's a little bit of an advanced command at this stage, but I want to show you the output, because I want to go through a practical usage of redirection and pipelines. So lots of output over here. And if you have a look inside of this tab, you can see it's a little bit of a fancy command. It's very bougie, isn't it? So let's have a look at top-b-n1, and you can see the redirector symbol being used. And I'm redirecting the output to a file called top. And remember, we learned about this technique called command substitution. Yeah, I'm wanting a file with the extension of today's date along with the current time. And what you can see is that a new file was created, and we're doing an ls over there, and you can see that there's a file called top. Now, if we want to look at the first couple of lines, of course, we use the head command. Remember that the head command is going to display the first 10 lines of a file. So here you can see the contents of that top-b-n1 command. Now, here's a cool example. I'm going to use the hostname CTL status command to show the properties of the current system. So we have things like the static hostname, the icon, the machine ID, the boot ID, and all other interesting bits of information. And what I want to do right now is that I want to use a pipeline. So I'm using the hostname CTL command, and I have a pipe symbol. And what I'm doing is that the output of that command is being sent as input to another command called T. Now, what the T command will do is that it will send the data that it received to a file. So the file that we're sending the data to is my system, and it will print it to standard out. So what you can see over here is that here we have the result of the hostname CTL command. And over here, you can see we have the contents of that my system file that was created by the T command. Now, one thing that you need to remember about using the T command is that it will overwrite any content inside of a file should it exist. But what we could do is that we could use the T command to append to an existing file. So yeah, I'm using the IPA command. We'll talk about what the IP command does a little bit later on. However, what I'm doing over here is that I'm sending the output of that command as input to T. But I'm using T with the A option. And the A option means append. And of course, you can have a look at the man page for how to use the T command. So I'm appending that to an existing file called my system. So you can see that the output of IPA is displayed on screen. And of course, you can have a look at the my system file to see that the content was appended. So I'm using cat my system. Here we have the output of hostname CTL. And here we have the output of the IPA command. Now, in terms of using standard error, I'm running the find command because all that I want to do is find files starting at the root of the file system that are larger than 100 megabytes in size. So you can see over here that it has picked up a few files, but also at the same time is that we have some error messages. So what I could do is that I could send the error messages to a different file, or I can discard them completely. So this is a common technique that I myself adopt. I use the find command, say where I want to look for the file, the size, and I say, don't show me the error messages, because sometimes the error messages could kind of mask the valid output. So by sending it to dev null, dev null is like, think of it as being the big black hole of Linux. Whatever you send over there, well, you can't ever retrieve it. It gets discarded. So what you can see over here is that we have the successfully processed messages, and we're not interested in the errors, right? They are discarded because they were sent to dev null. So if you have a look at this example over here, very similarly, I'm using the find command, and I'm just wanting to find files that are larger than 50 megabytes in size. And you can see the output over here. Here we go. Here's all the output. But what I want to do right now is that I want to send the output, both the successfully processed messages as well as the error messages. I want to send it to a file called 50 megabyte underscore plus underscore files.txt. So have a look at the command over here. You can see that I've got my find command, then an ampersand greater than sign. And what that means is that we're going to take the standard out and standard error, and we're going to send that through to plus underscore files.txt. Now remember, it is going to overwrite the content should you redirect in the same way. So what you could do is that you could just double up on that redirector symbol. And of course, now we would have two iterations of the find command's output. So you can see that here we have the output of the 50 megabyte plus files.txt. That's when we only had one iteration. And let's go and run that command a second time. And you can see now we have two iterations. Now, if you have a look at the output over here, and please don't do this, it's called UUOC, unnecessary use of cat. You don't ever have to use cat, then specify a file name, and then pipe it out to less. That's not at all needed. So what you could do straight away is that you could just say less etc sshd underscore config, for example. So please don't ever use the cat command and then pipe it out to less. It's not needed. Now, another example over here that I want to share with you is of using pipes is the WC command. And I kind of want to show you one of my favorite commands. So WC-L will count the number of lines inside of a file. So we're saying WC-L, and then the file that we are transacting against is sshd underscore config. And what we can see is that there are 132 lines inside of that file. Now, one of my favorite commands is this one over here. It's the grep command, and I'm wanting to show you the contents of the file sshd underscore config without any of the lines that begin with the hash. Now, generally inside of a configuration file, if a line begins with a hash, it's called a comment. In other words, that line is not included in the actual configuration file. It's not going to be interpreted by the process or the daemon or the service that uses that configuration file. So all that I want to do is show you how many valid configuration lines there are inside of sshd underscore config. So you can see that I'm using the grep command over here, separating it with a pipe, and sending it to WC-L. And you can see that we have 5 lines. Now, an important technique that I want to show you, and this is certainly most useful, especially when you're doing scripting, is called a year doc or a year file. So what is happening over here is that we are using cat, and we're going to send the output to a file called myfile. However, the input will come when the word or the characters EOF appear on a single line. So what you can see is that we have this prompt, that greater than sign, and that greater than sign indicates that this is a continuation of the command. So all that I had to do was type in, this is called a year doc or a year file. I hit enter. I continued my typing. A file called myfile will be created because that is what is specified after the greater than sign when the letters EOF appear on a single line. So EOF could appear in the middle of the line, at the end of the line. As long as it doesn't appear on a single line, you can continue editing that particular file. So what you can see over here is that I had EOF on a single line, and then the file finally got saved. And if you look at the contents of my file over here, you can see that it has exactly the text that I had entered in. This is called a year doc or a year file. A file called my file will be created when the letters EOF appear on a single line, like this. And of course, you can't see the EOF because that EOF terminates the instruction. So you can see over here that we are both using output redirection as well as input redirection. Now, another example, and a very simple one, of input redirection is using the cat command. So just as far as the concept is concerned, the cat command transacts against the file. So the cat command will show you the contents of a file to stand it out. And it obviously needs to transact against the file. So what is happening over here is that I'm using cat and I'm using a less than sign. Remember what the less than sign does is that it specifies input redirection. So we're saying instead of getting the input from the keyboard, get the input from a file called etc fstab. And you can see that the contents are displayed on screen. With that, it does bring this video to an end. I will see you in the next section. Hey everyone, right now we are going to have a look at editing text files with the shell prompt. And one of the reasons why we have this section and why it's so important is because we're going to talk about a very powerful editor called Vim. And we're going to use Vim to edit not just simple configuration files, but also a little bit further down the road when you take our awesome Ansible training, the RH294 class, you're going to learn about working with YAML-based files. You're going to work with editing Ansible configuration files. And you need an editor. And one of the most essential editors that we have is called Vim. Now, Vim is short for VI Improved. And once upon a time, we had this very basic editor, still powerful though, called VI. And right now, we make use of Vim. Vim is VI Improved. When you have the Vim Enhanced package installed on your system, then you have access to the Vim command. Now, once upon a time, it was the case when you were logged in as a normal user. When you typed in VI, it called Vim anyway. And if you really wanted to call VI, you had to put a backslash in front of the VI command. And what that does is that it prevents its alias from being summoned. Now, when you logged in as a privileged user, like the root user, for example, and you typed in VI, it actually called the VI binary. And VI and Vim have got very different features, which I'm not going to get into right now. But what I want you to understand is that now, with Red Hat Enterprise Linux 9, when you call VI, or when you call Vim, it calls the same program. It's going to call the Vim program. And the Vim program is so much more capable than the VI command. Now, let's have a look at a couple of things over here. When I type in Vim on its own, it says, hey, this is VI Improved. And you're thinking, well, where's the menu? I can't see the menu. Where's that file menu? Where's the edit menu? How do I deal with this right now? Now, in order for you to proceed, you need to understand the different modes that Vim operates in. Now, this mode over here is called command mode. And in command mode, this is where Vim takes very specific Vim commands. Now, if you want to edit text, then what you need to do is be inside of insert mode. Now, I want you to have a look at the bottom left corner of my screen. Can you see it has a whole lot of nothing there? Now, I'm going to hit I on my keyboard, and you can see the word insert that appears. Now, with Vim in insert mode, this is where I can edit text. This is where I can type in things like, my name is Ricardo da Costa. There you go. Now you're thinking, well, how do I save this file right now? Well, there's no file menu, there's no edit menu, there are no other of those typical menus that you become accustomed to. And again, you need to understand how Vim works. Now, I'm in insert mode. If I want to save this file, then I need to be in a special mode called extended command mode. Now, what I'm going to do is that I'm going to hit escape. Now, before I do that, have a look at the bottom left corner. You can see that the mode that I'm in right now is insert mode. Now, when I hit escape, the mode that I'm now in is the default mode. In other words, the mode that Vim is in when it starts up, which is command mode. I need to go to extended command mode. Now, how I do that is by using a colon. So have a look at the bottom left corner. You can see the colon that now appears with my flashing cursor. And now I can make use of additional extended commands like write. That is the command that we make use of to save the file. Now, no one really types out the word write because you could use W instead. So yes, let's go and backspace all of that out. Now, if I hit enter at this stage, it's going to give an error message because this file does not have a name, or this text does not have a name. So what I need to do is go ahead and create the file. So what I'm going to do right now is that I'm going to create it below var tmp, and we're going to call it about.me. Enter. And you can see right now that the file was written. Now, if you want to quit Vim, please don't use things like Control-C or Control-Z. Let me show you the right way to quit it. All you have to do is hit :Q. Remember : that takes us into extended command mode. And we're going to quit right now. Now, where's the file? The file is below var tmp. So let's go and open it up one more time. So Vim var tmp about me. And you can see there the file is. And look at the bottom left corner. You can see the path to the file. Now, the mode that I'm in is called command mode, and this is where Vim takes very specific commands. An example of a command would be YY. YY will copy an entire line. So what I'm going to do over here is use YY, and then I'm going to use P, another Vim command, to paste the text. Now, one of the cool things that we can do is that if you want to repeat a command, you could use a number and then the command. So what I did over there was use 5p. And you can see in the bottom left corner, we have 5 more lines. Similarly, if you want to delete a single line, you can make use of the dd command. Now, the dd command not only deletes the line, it can also be used to cut a line, which means that you can use p afterwards to paste. Now, what I want to do is that I want to show you a couple of other examples of Vim commands. So I'm going to use X, and X will delete the character that your cursor is on top of. So you can see that my cursor is now on top of the Y. I'm going to use X one more time. Now, let me go and take my cursor and put it over the I in is. And another example of a command that I have is DW, to delete a word. Now, I want you to remember that the mode that I'm in is command mode. I haven't changed into insert mode. Now, one of the other cool commands that we have is CW. CW stands for change word. So what it does is that it deletes the word, and then what it does afterwards is that it puts you into insert mode because the expectation is that you are wanting to make a change. So I could say CW, and look at that. It deleted the word Ricardo, and it now put me into insert mode so that I could replace it with something else. So what I'm going to do right now is that I'm going to return back to command mode. So look at my bottom left corner, escape. And what I'm going to do is that I'm going to put my cursor over the R in Rick, and then I'm going to use $. So what the $. does is that it deletes from your current cursor position until the end of the line. Now, I'm doing all of this using command mode, but I want you to understand that there are some other special modes that we have as well. For example, we have visual line mode. So look at the bottom left corner. Now I'm going to use Shift V, in other words, an uppercase V. And now you can see that visual line appears. And what I can do right now is that I can use my arrow keys and I can highlight lines, and then I could use D to delete them. Another mode that I would like to demonstrate to you is called visual block mode. So what I'm going to do is use Control V this time. And then I'm going to use my up arrow key. Then I'm going to use my right arrow key. And you can see what it's done right now is that it's selected the first 2 characters on the 2 lines that I have. Now let me go and hit the right arrow key a few more times. Now with the text selected, I'm now going to use X. Remember what X does is that it deletes characters. So what it did is that it deleted the characters that were highlighted using visual block mode. Now, one more thing that I'm going to demonstrate. I'm going to use Shift V, taking me into visual line mode. I'm going to use the down arrow key, and then I'm going to use a greater than sign. So can you see how it shifted the indentation towards the right? Now, I want to save the file in its current position. So what I could do is that I could use :WQ. Now, what :WQ will do is that it's going to write and quit. In other words, it's going to save and exit. Now, the same could be accomplished using command mode. Remember, :WQ is an extended command mode instruction. So what I could do is use an uppercase ZZ. So look at that. So save and exit. Let's going to open up that file one more time. And you can see that the file was indeed saved. Now, I'm going to delete the first line. And all that it says right now is Ricardo da Costa. A change has been made. So when I try and use :Q to exit, it says no write since the last change. And it says add an exclamation mark to override. So let me go and use :Q exclamation mark. And it allows me to safely exit right now without saving the file. Let's go and open it up one more time. And you can see that the 2 original lines that were previously saved are present inside of that file. Now, allow me to demonstrate one more thing to you, and I'm going to save the existing file to a new file, to a new path. And I'm going to use :W, and I'm going to say in my home directory, I'm going to call it Ricardo_da_Costa.txt. And look at that. I saved the existing text to a new file name. A common mistake that is very often made is that a file is opened up as an unprivileged user, and then changes are made. And you make all these wonderful changes to this file. However, you can't save it because you don't have the necessary permissions to do so. So what I'm going to do right now is that as the student user on server A, I'm going to use Vim, and I'm going to open up, let's just say Etsy FS tab, for example. And let's just say that I want to make a couple of changes over here. So look at where my cursor is right now. I'm going to use O. That will open up a new line, and it's going to put me into insert mode. So you can see that I'm inside insert mode right now, and this is where I can make some changes. So I'm going to say, for example, from nas.example.com, take share, we're going to mount it to MNT share. It is NFS version 4, defaults 00. Okay, so I haven't made a change. And now when it comes to saving the file, let me go and use escape, WQ to save and exit, or you can make use of X. And it says, oh, the read-only option is set. Add an exclamation mark to override. So you think, okay, I can override this, right? So let's go and try it out. WQ exclamation mark. And it says, can't open the file for writing. Now you go, oh, crud. I know what happened over here. I was logged in as an unprivileged user, and I'm trying to edit a file that I don't have permissions to. What can I do right now? So here's a little tip from me to you. Use :W because we're going to save it to a brand new file. So for example, var tmp fs tab. Enter. So the changes are now made to a different file. And what you can now do is that you could quit. Well, remember, if you try and quit right now, changes were made to the original file. So you've got to abort your changes. But we haven't lost our work because our changes was saved to a new file called var tmp fs tab. So now what you can do with the necessary privileges, for example, you could use sudo, or you can make use of su. You could copy the file from var tmp fs tab to the original file that you had intended editing. So let me go and demonstrate that. Su dash, the password is Red Hat. Now I'm going to copy var tmp fs tab, and we're going to copy it to etc fs tab. And it says, yes, we're going to go ahead and override. And let's go and open up fs tab right now. And there are the changes. Nice and simple. Of course, that nas.example.com is not a valid example, so I'm just going to go and delete that entry, DD. Then I'm going to use Shift ZZ, and that will save and quit. Now, Vim does have a configuration file, and the global configuration file for Vim is etc vimrc. Now, as a normal user, you won't be able to edit that file. And what that file does is that it influences the behavior of Vim. However, every single user can have their own personal Vim configuration file, and they could create a file in their home directory called .vimrc. Remember, any files that begin with a dot, with a period, are typically hidden from normal view. And if you want to display them using the ls command, you need to make use of the A option. So what I'm going to do is just open up .vimrc, and you can see that I've got a couple of options over here. This is most useful when it comes to using YAML-based files. So what I'm doing over here is that I'm saying, let's go and apply some options specifically when YAML-based data is detected. So it's an auto command. It's going to run automatically with the file type YAML. And we don't care about the extension, whether it's .yml or .yaml. We don't care about the extension. We care about the file content. And what we're going to be doing is setting a bunch of local options. Now, the local options are specific to the YAML files. In other words, these are options that are not going to be applicable to any other file types, like XML files, like JSON files. And you can see that I have a bunch of options over here that are in place. Now, if you want to make use of any options that are going to be applicable to all files, let me give you a quick little example of that. I'm just going to use Vim. etc fs tab. Look at the color over there. And I'm just going to quit that. And I'm going to open up a new line. And I'm going to say color. And I'm going to change the color profile to desert, for example. It's going to open up that same file. And you'll see that the color is different. And that is going to be applicable to all files because it's a setting for the Vim program itself. As opposed to, let's go and open up that vimrc file. The line above over there, you can see that it's only applicable to YAML-based files. So let's just say that we want to enable line numbering for all files. In other words, whenever we make use of the Vim command, line numbering must be enabled. So what I'm going to do right now is that I'm going to use O and set NU, and that will enable line numbering. So let's go and save and quit. We're going to open up that vimrc file one more time, and you can see right now that line numbering is enabled. Vim is a really, really powerful editor, and there's so much that I can show you, but I promise this is just going to be the last one. What I'm going to do right now is that I'm going to open up Etsy SSH sshd_config. Now, be mindful that I'm logged in as a normal user. And it says permission denied. Oh dear. So of course, what I could do is that I can make use of either sudo or I can make use of su. So let's just say that I want to make use of sudo. Remember, I have this technique where I can make use of a double exclamation mark. So sudo space bang bang, like that. It asks me for my own password. I type in student, and there you go. I've opened up the file. Now, if you want to go to a particular line, all you need to do is use colon and then the line number. So for example, 40. And that will take me right now to line number 40. The best way to learn how to make use of Vim is to use the Vim tutor. So let's go and open up a new tab, and it's as simple as typing in Vim tutor. And it's an interactive tutorial as how you would make use of Vim. So for example, it says lesson 1, how you would go about moving the cursor. So what you could do is that you can make use of up, down, left, right. Or what you could do is make use of HKJL. In the event, of course, that your keyboard does not have an up, down, left, right arrow keys. What's going to happen in the guided exercise is that we will be going through a few of these lessons. Now, we don't have time to go through every single one of the lessons, and here's why. I want to go to the end of this particular file. So use an uppercase G to go to the end of the file. I'm going to use page up, and you can see that we have 7 lessons. So we don't have scope to go through every single one of these lessons. So head on over to the next video where we'll be meeting you for the guided exercise, where we will be using the Vim tutor to go through lesson 1. Hey everyone, let's go and explore the power of Vim by going through the guided exercise called Edit Text Files from the Shell Prompt. As always, we need to get things kick-started by running the appropriate start script. For this activity, we run the command lab start edit file, making sure that we have that success before proceeding. So what we're told to do is make an SSH connection to server A as the student user, and we're going to go through the Vim tutorial. And how we do that is by running the command vim tutor. We will be going through lessons 1.1 through 1.6. Now, lesson 1.1 is all about moving the cursor. And you can see over here that what we could do is use HJKL to move around in the event that we don't have arrow keys. Of course, we can make use of the arrow keys if we have them available on our keyboard. So it tells us, move the cursor around the screen until you are comfortable. So of course, J will take us down, L will go to the right, H to the left, and then K back up. Now, when you're comfortable, you can go down to lesson 1.2. So let's have a look at lesson 1.2. It says, note, and this is a worthwhile note, before executing any of the steps below, read this entire lesson. So press the escape key to make sure that you're in normal mode, and then you would type in :Q ! Which means that we're going to be exiting the editor, discarding any changes that were made. And then we can get back over here by executing the command that we used to get into the tutorial, which is vim tutor. Now, if you have these steps memorized and are confident, then you can execute steps 1 through to 3 to exit and then re-enter the editor. So remember, :Q ! will discard any changes that were made. So let's go ahead and do that right now. :Q ! And let's go back inside of it. Now, I'm going to use page down because I have page down available on my keyboard. And I'm going to scroll down to lesson 1.3. And it's all about editing, text editing, deletion. And it says, press X to delete the character under the cursor. And it says, go ahead, move the cursor to the line below, marked with 3 dashes and then a greater than sign. And it says, to fix the errors, move the cursor until it is on top of the character to be deleted. Press the X key to delete the unwanted character. Repeat steps 2 to 4 until the sentence is correct. So let's go navigate over there. So what we're going to do right now is put the cursor over 1C. The cow jumped over the moon. Yeah, that looks right. Okay, now that the line is correct, we can go over to lesson 1.4. So lesson 1.4 is all about inserting text. And what we could do is press I to insert text. So again, read the instructions before actually making changes. And it says, move the cursor to the first line below, marked with 3 dashes and then a greater than sign. To make the first line the same as the second, move the cursor on top of the character before which the text is to be inserted. Press I and type in the necessary additions. As each error is fixed, press escape to return to normal mode. And then we could repeat steps 2 to 4 to correct the sentence. So over here, I'm going to put my cursor over the T in text, hit I. I'm in insert mode right now. And I'm going to say there is some text missing from this line. Of course, now that they are the same, what we could do is move on to the next lesson, lesson 1.5, which is all about appending text. Now, what we need to do is be mindful that we're still in insert mode, so hit escape to return to normal mode. So lesson 1.5 says, move the cursor to the first line below, marked with 3 dashes and a greater sign. It doesn't matter on what character the cursor is in that line. Press A to type in the necessary additions. As the text is being appended, hit escape to return to normal mode. Move the cursor to the second line marked with 3 dashes and a greater than sign, and repeat steps 2 and 3 to correct the sentence. So what we're going to do right now is, it doesn't matter where we are, which character our cursor's on, use A, of course that's an uppercase A, And let's go and edit the line. There is some text missing from this line. Let's go and use escape. And we're going to scroll down. And again, it doesn't matter which character your cursor's over. Use an uppercase A right now. And we're going to append text. And it says, there is also some text missing. Yeah. Now that the lines look the same, we can hit escape. And we can go to the 6th and final lesson. So it tells us that it's all about using :WQ to save a file and to exit. And it says again, really importantly, read the entire lesson before you actually begin. It says, exit the tutor as you did in lesson 1.2 using :Q!! Or if you have access to another terminal, do the following there. And it says, at the shell prompt, type in this command, vim space tutor, enter. So vim is the command to start the editor, tutor is the name of the file that you wish to edit. And use a file that may be changed. And it says, insert and delete text as you've learned in the previous lessons. And it goes along and says, save the file with changes and exit with :WQ. And if you have quit Vim Tutor in step 1, restart the Vim Tutor and move down to the following summary. After reading the above steps and understanding them, do it. So let's go and use :Q!! And what we're now going to do is use vim space tutor. And now we can start editing text. So, hello everyone, escape :WQ. And of course, a new file has been created called tutor. Finally, what we just need to do is go down to the lesson summary. And it goes through what we've learned. Of course, feel free to continue the learning and have a look at the other lessons. There are 7 of them in total, and you may need to set aside about 30 minutes to 45 minutes to go through them all. When you're satisfied with your work, go ahead and run the command lab finish edit file. Of course, this needs to be run from the workstation machine. And with that, it does bring this video to an end. I will see you in the next section.